Good day everyone. My name is Elvin Don Barong, the presenter of the part of Foundation Engineering title Framing. Framing. Frame construction is a building technique which involves building a supportive framework of studs, joists, and rafters, and attaching everything else to this framework. This building style can be accomplished very quickly with a skilled crew, and it is extremely common all over the world. So, uh, Framing in civil engineering refers to the process of constructing a building structure using various materials such as wood, steel, or concrete. It involves creating a rigid framework and supports the building weight and shape. Framing is a critical aspect of construction as it ensures the stability and safety of the building. The framing terminology, the studs. It's a vertical framing members used to create walls, joists, horizontal framing members used to support floors and ceiling, rafters, sloping framing members used to support roofs, the headers, beams placed or over doors and window to support the weight above, sills, beams placed at the bottom of walls to support the weight above, trusses, triangular shaped frames used to support roofs and bridges. Girders, large beam used to support other beams or columns. The columns, vertical support used to transfer loads from the structure to the foundation. The foundations, the lowest part of the building that transfers loads from the structure to the ground. Walls. Wall framing in house construction includes the vertical and horizontal members of exterior walls and interior partitions, both of bearing walls and non-bearing walls. These thick members, referred to as studs, wall plates and lintels, sometimes called headers, serve as a nailing base for all covering material and support. The upper floor platforms, which provide the lateral strength along a wall. The platforms may be the box structure of a ceiling and roof or the ceiling and floor joist of the story above. In the building trades, the technique is variously referred to as stick and frame, stick and platform, or stick and box, as the stick studs gives the structure its vertical support, and the box-shaped floor sections with joists contained within length-long posts and lintels, more commonly called headers, support the weight with joists contained within the support the weight of whatever is above, including the next wall up and the roof above the top story. The platform also provides the lateral support against wind and hold the stick walls true and square. Any lower platform supports the weight of the platforms and the walls above level of the component headers and joints. Exterior wall studs. Wall framing in house construction includes the vertical and horizontal members of exterior walls and interior partitions. These members, referred to as studs, wall plates, and lintels, serve as a nailing base for all covering materials and support the upper floors, ceiling, and roof. Interior partitions. Interior partitions supporting floor, ceiling, or roof loads are called load-bearing walls. Others are called non-load bearings or simply partitions. Interior load-bearing walls are framed in the same way as exterior walls. Studs are usually 1.5 inches by 3.5 inches. Lumber spaced at 16 inches or 410 mm on center. This spacing may be changed to 12 or 12 inches or 300 mm or 610 mm depending on the load supported and the type of thickness of the wall finish used. Lintels or headers. Lintel, lintels or headers are the horizontal members placed over one window, door and other openings to carry loads to the adjoining studs. Lintels are usually constructed of two pieces of 2 inches nominal 38 mm lumber separated with spacers to the width of the studs and nailed together to form a single unit. The preferable spacer material is rigid insulation. The depth of a lintel is determined by the width of the opening and the vertical load supported. Wall section. The complete wall section are then raised and put in place. Temporary braces added and the bottom plates nailed through the subfloor to the floor framing members. The braces should have their larger dimension on the vertical and should permit adjustment of the vertical position of the wall. Balloon frame structures. While this is an outmoded form of wood construction no longer used today, it is good to know that it is and why it is no longer used. In balloon frame construction, if you had a two-story house that was 20 feet high, you would use a single 20-foot long vertical stud for both stories. This made the studs heavy and difficult to handle. The second problem was the gap between the two studs, which acted passageways for the spread of the fire from the lower to the upper story. Platform framework structures. This is the sequence you would follow to erect a two-story platform from house. Number 1. Erect the ground floor platform, a horizontal wooden platform over the foundation. Number 2. Build all the walls up to a height of 1 story. This can easily be done by building each wall flat on the floor platform and then tilting it vertically. Number 3. Build the next floor platform. Number 4. Erect the next set of vertical walls in the same manner on the top of the second platform. Number 5. Build the sloping roof over the walls. As you can see, this system uses shorter, lighter studs that are easy to handle. It is much easier to build walls flat and then tilt them into place. Since each floor is separated horizontal platform, this makes it convenient for construction workers to move around. These platforms also break the vertical spread of fire. The only disadvantage of platform frame versus balloon frame construction is that wood shrinkage plays a bigger role in platform frames. This PowerPoint is all about framing by the topic Foundation of Engineering. It is indispensable in the construction industry. It encompasses structural integrity, safety considerations, technological advancements, integration with building systems, and regulatory compliance. The foundation of engineering underpins these aspects, ensuring the frame structures are not only robust but only sustainable and compliant and industry standard. With the rapid development of the construction industry, the building technology needs to be improved day by day. The application of the reinforcement concrete frame structure is suitable for all kinds of projects for its strong seismic capacity, good integrity, and durability. This paper introduces the structuristic of the frame structure, discusses the problems existing in the two important works of reinforcement and formwork, and introduces the correct construction technology. Finally, it expounds the construction method of the frame structure of the construction engineering, and the effectivity was demonstrated in the concrete frame structure cases. And that's the part of my report. That's all. Thank you.